Two brothers, Owen and Peter, began work in 2005 on starting salaries of $20,000 and $17,000 per annum respectively. So Owen was earning $20,000, Peter earning $17,000 to start off with. Owen's salary increased by €500 per annum per year, and Peter's salary increased by €1,250 per annum per year. This salary pattern will continue. Part A. Complete the table showing the annual salary of each brother for the years 2005 to 2010. So basically fill in these boxes. In what year will both brothers earn the same amount? Part C. Owen claims that their salaries over the years can be represented by an arithmetic sequence. Explain what an arithmetic sequence is. Do you agree with Owen? Explain your answer. Part D. Find in terms of n a formula that gives Owen's salary in the nth year of the pattern. Using your formula or otherwise, find Owen's salary in 2015. Part F. Find in terms of n a formula that gives the total amount earned by Peter from the first to the nth year of the pattern. G. Using your formula or otherwise, find the total amount earned by Peter from the start of 2005 up to the end of 2015. H. Give one reason why the graph below is not an accurate way to represent Peter's salary over the period 2005 to 2011. So Part A, complete the table showing the annual salary for each brother for the years 2005 to 2010, and in what year will both brothers earn the same amount. So first of all, it's important to note that year 1 is 2005. Year 2 is 2006, Year 3 is 2007, Year 4 is 2008, Year 5 is 2009, and Year 6 is 2010. So Owen's salary increases by €500 a year, and he started at 20,000. So Owen started at 20,000, and Owen increased by 500 per annum or per year. So we need to add 500 to 20,000 and continue like that. So 20,000 plus 500 is 20,500, plus 500 is 21,000, plus 500 is 21,500, then 22,000, then 22,500. So Peter's salary started at 17,000. So Peter's salary started at 17,000 and increased by 1,250 per year. 1,250 per annum or per year. So 17,000 plus 1,250 is 18,250. 18,250 plus 1,250 is 19,500. 19,500 plus 1,250 is 20,750. Add on another 1,250 gives us 22,000. Add on another 1,250 gives us 23,250. And clearly, in year 5, which is 2009, both brothers earned 22,000. So the year both brothers earned the same amount, 2009. Part C. Owen claims that their salaries over the years can be represented by an arithmetic sequence. Part 1. Explain what an arithmetic sequence is. Part 2. Do you agree with Owen? Explain your answer. So what is an arithmetic sequence? Well, it's a sequence where the first difference between each term is the same or constant. Do I agree with Owen? And explain my answer. Yes, I agree that this is an arithmetic sequence because a constant amount, the same amount, is added to his salary in any year to give his salary for the following year. So the same amount is added each year, a constant amount. So yes, this is an arithmetic sequence. Part D. Find in terms of n a formula that gives Owen's salary in the nth year of the pattern. So, Owen started off on 20,000. The following year he was on 20,500. The following year 21,000 and so on. So term 1 is 20,000. Term 2 is 20,500. Term 3 is 21,000 and so on. So to find the nth term of a linear or an arithmetic sequence, we can either use the formula in the formula tables or we can use the zero-term method. So these are the steps involved in the zero-term method. We find the difference. So to get from 20,000 to 20,500, we're adding on 500, so the difference is 500. Then we stick on an n, so we get 500n, and then we find the zero term. So if this is term 1 and we're going up by 500, then to go back by 500 we end up on 19,500. So it ends up being 500n plus 19,500. So this is our nth term for the arithmetic sequence for Owen's salary. E. Using your formula or otherwise, find Owen's salary in 2015. So to find Owen's salary in 2015, we can use the nth term formula, which is 500n plus 19,500. But we need to figure out which term represents the year 2015. So term 1 is 2005, term 2 is 2006, term 3 2007, term 4 2008, term 5 2009, term 6 2010, term 7 2011, term 8 2012, term 9 2013, term 10 2014, and term 11 2015. So year 11 or term 11 is the year 2015. So we need to substitute 11 in place of the n in our nth term formula. So it becomes 500 multiplied by 11 plus 19,500, and we end up getting 25,000 euro. So Owen's salary in 2015 will be 25,000 euro. Find in terms of n a formula that gives the total amount earned by Peter from the first to the nth year of the pattern. So Peter started at 17,000, then he went up to 18,250, then 19,500, and so on. So in order to find a formula for the total amount, we're going to use the sum of series formula given to us in our formula tables. So we need to figure out what the A is. The A represents the first term, and the D the common difference. So A is going to be 17,000 because that's our first term. 17,000 equals A. And our common difference is going to be 1,250. So D is 1,250. So we swap the A for 17,000 with brackets around it, and we swap the D for 1,250 with brackets around it. So 2 by 17,000 is 34,000. N by 1,250 is 1,250n. And minus 1 by 1,250 is minus 1,250. So we get n over 2 times 34,000 plus 1,250n minus 1,250. N over 2 can be written as a half n. 34,000 minus 1,250 is 32,750. We bring down the plus 1,250n. A half n multiplied by 32,750 is 16,375n. So a half of this is this. And a half n multiplied by 1,250n is going to be 625n squared. So a half of this is 625, and n by n is n squared. So our formula for the total amount earned by Peter from the first to the nth year of the pattern is 16,375n plus 625n squared. So using your formula or otherwise, find the total amount earned by Peter from the start of 2005 up to the end of 2015. So the formula that we got was 16,375n plus 625n squared. We're interested in how much he's earned up as far as 2015. So 2015 is 11 years in total, from 2005 to 2015, because it's the start of 2005 up as far as the end of 2015. So it does actually cover 11 years. The start of 2005 to the end of 2015 is 11 years. If this said from the start of 2005 to the start of 2015, it would be 10 years. But because it's to the end of 2015, we add on one more year, so it's 11 years in total. So we swap the n for 11 with brackets around it. So we get 16,375 times 11 plus 625 times 11 squared gives us 255,750 euro. Now, alternatively, we could have substituted 11 into our formula from our formula book, our sum of series formula. So swapping the n for 11, the number of years is 11. the first term is always the A, which was 17,000. So 17,000 times 2 would be 34,000. We would swap the N again for 11 and the common difference of 12, 1,250. And we would still get the same answer. Give one reason why the graph below is not an accurate way to represent Peter's salary over the period 2005 to 2011. So this is our x-axis representing the years from 2005 to 2011, and this is our y-axis representing his salary from 0 to 4,000, 8,000, 12,000, 16,000, 20,000, 24,000. And we can see that it starts at about 17,000 in 2005 and goes up as far as around 23,000 in 2010. So why is this not an accurate way to represent Peter's salary? Well, the graph shows Peter's salary increasing constantly throughout the year, but his salary only increases at the end of each year. So this is not correct. Because it is a constant straight line, it would indicate that every single day his salary is increasing. But this is not the case. His salary only increases at the end of each year. So if anything, if we wanted to draw out this as a graph, it would look more so like this. Which would represent that it increases only at the end of each year.